Hi, I'm Ken Black. Welcome to Business Statistics for Contemporary Decision Making. Today we're going to learn how to solve written or word probability problems, which is difficult for many of us. Let's start off with an example in the fast food industry. Suppose that 60% of managers in the fast food industry are males. Suppose also that 20% of these managers, or 20% of the managers in the fast food industry, are under 30 years of age. In addition, we know that 15% of all fast food managers are males and under the age of 30. So what do we have here? Well, our first two probabilities are actually marginal probabilities. So let's let M denote a male, and let's let A denote under 30. So what do we have here with probabilities? Well, we have the marginal probability that a fast food manager is a male is 0.60, taken from this statement. We know that 20% of managers of fast food restaurants are under age 30, so the probability of A is 0.20, two marginal probabilities. The question might be, what probability does this statement represent? Well, we've learned that generally when we use the word and, or if we use the word both, that is, if we use the word and, both, then we have an intersection. So the intersection that we have here is the probability that a fast food manager is a male and is under age 30. And that's represented by about 15% of the population. Using these particular figures and this information, let's construct a probability matrix to help us solve our problem. So how do we use the information that we've gathered on this particular problem to solve for probabilities using a probability matrix? Well, we have two marginal probabilities given. The probability that a manager is a male is 0.60, so we go to the yes row and we put a 0.60. From there we know that since the total of this particular column is 1 and this is 0.60, then this probability is 0.40. That particular probability is the probability that the fast food manager is not a male or is a female. And we can actually write that down if we'd like. Probability they're not male is 0.40. Now we can take the other marginal probability, the probability that the manager is under age 30, which is 0.20, go to the bottom of the yes column and put 0.20. And using similar logic to what we've done before, we can see that this probability is 0.80 because these two must add up to 1. But what is this the probability of? This is the no column under the less than 30 age. So the probability that a manager is not less than 30 is 0.80. So by having two of the marginal probabilities, we're able to solve for all of the other marginal probabilities. Let's focus on this particular probability. This probability is the intersection that the manager is male and under 30. So this particular probability, 0.515, would go in the yes cell or the intersection of male and under 30. So let's place it there. Once we place one intersection in a 2x2 probability matrix and we have all the marginal probabilities given, we're able to solve for all the other cells or all the other intersections. Subtracting 0.15 from 0.60 results in 0.45. This is the probability that the fast food manager is a male, yes, but not under age 30. So we can write that over here. The probability that they are male and not under 30 is 0.45. Continuing the process, we subtract 0.15 from 0.20, resulting in 0.05. That's the probability that a fast food manager is not a male and is under age 30. And then we have this last cell that we still have to solve for, subtracting 0.45 from 0.80, resulting in 0.35, we have the probability that a person that's a fast food manager is neither a male nor are they under age 30, or the neither nor cell. Let's look at a second example of how we can solve written or word probability problems using the probability matrix. Let's consider now managers in the computer software industry. Suppose that the managers in the computer software industry, that 80% of them have a college degree. Suppose, in addition, 60% of managers in the computer software industry have experience as programmers. Suppose that 70% of managers in the computer software industry who have experience as a programmer also have a college degree. That is, 70% of those with experience have a college degree. Let's let C equal college degree, and let's let E equal experience as a programmer. Using mathematical symbols for probability, we can state then that we have the marginal probability, the probability of C, or the probability that you have a college degree, given that you're a manager in the computer software industry, is 0.80, and that the probability that you have experience as a programmer is 0.60. So we've written out in mathematical symbols these two particular statements. Commonly, a more difficult statement to convert into mathematical symbols is represented by this third statement. So we have to think about, what is it? Is it 70% of all the managers, or is it 70% of some subset? Whenever you're dealing with a subset of the population, you're dealing with conditional probabilities. In this particular case, what is our subset of the population? Is it 70% of all managers in the computer software industry or not? Well, no. It's actually 70% of those who have experience. In other words, given that you have experience, there's a 70% chance that you have a college degree. So when we begin to write this particular conditional probability, we want to start off focusing on what is the given part, what is the symbol or the letter that we put to the right. Well, since it's 70% of those with experience, experience goes here as a given condition. And that equals 70%. 70% of those with experience have a college degree. So we write the college part here, and we read this: the probability that you have a college degree, given that you have experience as a programmer, is 0.70. We're now going to use these probabilities to construct a probability matrix and solve problems. Let's solve for this probability matrix using the probability information that we've just generated. It turns out that the probability matrix we made in the first example is actually the simplest probability matrix to make. That is, a probability matrix where two of the marginals are given and the intersection is given. You merely have to enter the information into the matrix, solve for the other cells, the other marginals, and you can solve all other probabilities from there. In this particular problem, we have a little different situation. We have the two marginals given, but we have a conditional probability. Let's see how that affects or impacts our problem. The probability that a person has college is 0.80. We'll put that here with yes. And of course we know by now that this probability would be 0.20 because 0.80 and 0.20 must add up to this complete total, which is 1.0. So 20% of all these managers do not have a college degree. 60% of the managers have experience as a programmer. We'll put this right here under the yes column. And therefore, 40% of the managers do not have experience as a programmer. If we just knew one of these intersections here, we could use all of these marginal totals to solve for the others. Unfortunately, what we have is a conditional probability. The conditional probability does not belong directly in the matrix. So we have to use this conditional probability to spring, if you will, one of the probabilities in these cells or to solve for that particular probability. Let's see how that's done. Once again, as always, when we're dealing with a conditional probability, we focus on the characteristics that's to the right of the sign, the right of the line, which in this particular instance is the E. If we take that and we locate where the E values are, and they are in this column, we know then that 60% of all the managers have experience. But we also know from this conditional probability that it is given that they have experience. That means we're really not interested in the 40% that don't have experience. So what are we saying here? 70% of the managers that have programming experience have a college degree. So let's come down here and take 70% of the 60%, because 70% of the 60% have a college degree. Most of us learned very early in our education that if we're taking 70% of some other number, that we do this by multiplying, and that's the case here. If we take 70% of 60%, then we have 0.70 times 0.60, and as a result we have 0.42. Since both the C and the E were yes, then the answer 0.42 lies in the yes, yes cell, or they have a college degree and they have education. So let's review what we just did. We took 70% of the 60%, resulting in 42% of all the managers who have a college degree and experience. Mathematically, how are we able to do this? If we were to take the intersection of experience and college and rewrite it using the probability formulas, it would be written out as the probability of E or experience times the probability of college given E. In this particular case, we were given the conditional probability, and we also knew the marginal probability, which was 0.60, resulting in 0.42. So when we actually took 70% of the 60 and got the 0.42, we were merely using the probability formula in our heads, so to speak. Once we have one of these cells solved for, we can solve for all the other cells. As a result, we have 0.18 here, 0.38 here, and 0.02 here. And from there, we can solve for virtually any other probability that we want to know.